Hi, welcome to this How Do I video on handling file management in CAL code when running in Microsoft Azure. This video is a part of the Microsoft Dynamics NAV Managed Service for Partners. In this video, you'll get to know the Microsoft Azure File Service and how to use it from CAL to manage file operations. This video will cover the file handling topic in 3 steps. First, I'll create a new Microsoft Azure storage account. Then I'll write and test the CAL code. Since this video is a part of the Microsoft Dynamics NAV Managed Service for Partners series, I'll test my CAL code from Managed Service tenant. Let's get started. Storing files in the NST file system on the server will not work properly in many scenarios where you cannot guarantee that 2 sessions that require the same file will have access to the same physical file system. This may be in all on-prem scenarios when you are using load balancing, but also in all managed service scenarios. In these scenarios, you may want to store files in Microsoft Azure Storage. The first step for me is to create a storage account. In my Microsoft Azure Management Portal, I'll click the New icon, then select Data plus Storage, then Storage Account. I'll choose the classic deployment model, then click Create. In the Storage Account page, I'll enter the name, then click Type, then select the geo-redundant type of the account, and click the Select button. Then I'll click Select Existing Resource Group, and then click Not Configured, and then choose one of my existing resource groups. I'll choose not to pin the new storage account to my dashboard, and then I'll click Create. After a while, my account will be provisioned, and I'll be able to access it from the list of my Azure resources. Let's take a look at the CAL code now. Here, I have a number of objects that I prepared to handle my Azure File Service operations. First, there is a setup table where I'll store my account name and access key. Of course, there is a page that allows me to manage that information. The heart of this walkthrough is the Azure File REST API code unit, which contains the necessary functions to manage all REST communication with the Azure File Service. Let's take a look at its functions. First, there are 2 functions to return the information from the setup table I've shown a moment ago. Since all of HTTP requests to the file service have to contain some common information, I have the create HTTP request function that creates a new HTTP request. It receives the resource identifier, such as file share or file, and verb, which corresponds to the HTTP method. The getRoot function it invokes simply formats the root URL from the common format which contains the account name and the common Azure File Service base URL. I also assign the necessary headers that are defined by the Azure File Service REST API requirements, and the HTTP web request instance is now configured for requests. All Azure Storage REST requests have to be authorized, and the authorization token must be sent as a header to the REST endpoint. Authorization token is a string in specific format defined by Azure Storage API that is signed by the storage account access key. To create that string in the specific format, I have to construct it from the verb, content type, canonical list of headers, storage account name, canonical list of resources, range information, and content length. For most of these, I have helper methods. My getCanonicalHeader function retrieves all XMS headers, sorts them, and then formats them into a single string according to the formatting rules explained in the Azure Storage REST API documentation. The getCanonicalResource function takes the URL without the initial / character and then returns the remaining part if it contains no question mark character, or otherwise formats the query string parts according to the rules explained in the documentation. Then, my getRange function formats the range header if present and returns it as a string. If no range header is present, it will simply return an empty string. Then, the getContentLength function will return the formatted content length if it is greater than 0, or otherwise it will return an empty string. And finally, my authorize function encodes the constructed signature string with the configured key using the HMAC SHA-256 algorithm and assigns the result to the authorization header as described in the Azure Storage REST API documentation. The last common function we have is the invokeRequest function. It first authorizes the request using the authorize function I've shown, and then calls the getResponse try function. It's a simple function that sends the request to the REST endpoint and retrieves the response. Since it's a try function called with inspection of its Boolean result, it won't break the execution. If it succeeds, the response is closed, otherwise the web exception object is retrieved and a meaningful error message is shown to the user. This was the infrastructure part. Now I have 3 demo functions that consume this infrastructure to perform specific REST operations, creating a file share, creating a new blank file of a specific length, and uploading content to an existing file. First, the createShare function creates a new request with a URL in the required format prescribed by the REST API, then explicitly sets the content length to 0, which is also mandated by the API, and finally calls the invokeRequest function. Then, the createFile function creates a new request with required URL constructed from the share and file names, then sets content length to 0, and then sets the necessary headers for the createFile operation. Finally, it calls the invokeRequest function. Then, the uploadFile function also creates the request from the URL in the required format, sets the content type, and then sets the necessary headers, and finally writes the content received as a byte array to the request stream. Finally, it calls the invokeRequest function. Then I have 3 demo code units, each of which calls each one of these API functions. CreateShare is simple and it invokes the createShare function. CreateText file first converts the UTF string into a byte array, then it creates a new text file with the necessary length retrieved from the byte array, and finally uploads the byte array to the created file and specifying the content type of the uploaded content. The last code unit retrieves the first employee, then retrieves the stream from its picture, then creates a new memory stream and copies the in-stream content into it. Finally, it creates a new JPEG file with the required length and then uploads the content of the memory stream to this file. And the last, I have customized the default role center to include the actions to show my setup card and to invoke these 3 code units to test if my functionality works. I'm now in my NAV client for my demo tenant. I'll click the Azure Storage Setup action. I have to provide my account name and access key. I can get this information from my Azure Storage account. Back in my Azure Management Portal, in the Storage Account Settings page, I'll click Keys. When the Manage Keys page loads, I see all the needed information here. I'll copy the storage account name and paste it into the account name field in NAV, and then I'll copy the primary access key and then paste it into the access key field in NAV. Then I'll close the page. Next, I'll click the CreateShare action, and when it completes, I'll go back to my Azure Management Portal. In my storage account page, I'll click Files. This will show the list of shares, which now includes the Vieco share. I'll click it to verify that it's empty. Then, back in NAV, I'll click the Create Text File action, and then go back to Azure Management Portal, refresh the Vieco share to verify that there is now the Hello World text file. When I click the file and then click Download, I can verify that it contains the content uploaded by NAV. Finally, back in NAV, I'll invoke the last demo action to create an image file. Back in Azure Management Portal, I'll refresh my share, verify that there is a new JPEG file, then click the file and then click Download to verify that it contains the image uploaded by NAV. Let's wrap up. In this video, you have seen how to create a new Azure Storage account and then how to consume the file service REST API functionality to write to this account from CAL. The topics covered in this video include how to consume REST web services from CAL by using standard .NET Framework functionality through .NET Interop. Then you have learned about the Microsoft Azure REST API on the example of the File Service API. And finally, you've learned how to authenticate Azure REST API calls. To learn more about the Microsoft Dynamics Managed Service for Partners, please visit http://aka.ms/NAV Managed Service. Find the detailed Azure File Service REST API documentation on the link provided here. Also, all sample code I demonstrated here is available on GitHub. It is provided as is with no warranties or support, and you use it entirely at your own responsibility. I hope you enjoyed this How Do I video. Thanks for watching, and come back for more videos in the Microsoft Dynamics NAV Managed Service for Partners series.